Let's go. Question 1. What is the kinetic energy equation in simple form? Also, rearrange it to make V the subject. Even though you probably won't have to remember equations because they'll be in the formula sheet, people who remember the equations do better. The equation is E equals half mv squared. That's kinetic energy equals a half times mass in kilograms times speed squared in meters per second. Rearranged, V equals the square root of 2E over divided by m. Question 2. What is the equation for gravitational potential energy, GPE, and how high off the ground is a 500-gram ball if it has 100 joules of GPE? Let's say that G, gravitational field strength, is 10 in this case. The equation is E equals mgh. GPE equals mass in kilograms times gravitational field strength, or G. You might just say gravity as well, times height in meters. Rearranging for h, we get E divided by m times g. So 100 divided by 0.5 times 10. Did you remember to convert grams to kilograms? 500 divided by 1000 is 0.5. So it's 0.5 kilograms. Don't forget that when you're dividing by two things on the bottom you must use the fraction button on your calculator or use brackets around the two numbers. Question 3. What is the definition of power, and how much energy does a 5-watt light bulb use in an hour? Power is the rate of energy transferred or rate of work done. Work done is just another fancy term for energy transferred. Any rate is something divided by time. So power equals energy divided by time. P equals E divided by T. Rearranging to make energy the subject, we get P times T. So 5 times 3600 is 18,000 joules, or 18 kilojoules. The 3600 is just 1 hour in seconds, which is what it has to be in order to go into the equation. Question 4. The 5-watt light bulb only emits 3 watts of light. What is its efficiency as a decimal and percentage? Efficiency is just a ratio of useful energy out divided by total energy in. This gives us 0.6 as a decimal. Multiply it by 100 and it turns into a percentage, 60%. Question 4. The 5-watt light bulb only emits 3 watts of light. What is its efficiency as a decimal and percentage? Efficiency is just a ratio of useful energy out divided by total energy in. This gives us 0.6 as a decimal. Multiply it by 100 and it turns into a percentage, 60%. Question 5. The equation for current is I equals Q divided by T, or you might see a rearranged version Q equals IT in your formula sheet already. What are the units for current I and charge Q? Current is measured in amperes. Usually we just say amps for short, but we just write A. Charge is measured in coulombs. They're groups of electrons essentially. Current tells us the rate of flow of charge in coulombs per second. So a current of 10 amps, say, means that 10 coulombs are passing every second. Question 6. What is Ohm's law, and how can it be used to find the resistance of this resistor from its graph? Ohm's law is V equals IR voltage. All the balls prefer you to say potential difference, or PD. That's measured in volts. That's equal to current in amps times resistance in ohms. Rearranging, we get R equals V divided by I. So we just pick a nice point on the line on the graph and divide the PD by the current. You'll get the same answer no matter what point you pick, but only if it's a straight line. By the way, this shows that this has a constant resistance, so we can say that it's an ohmic resistor. Question 7. The graph for a filament bulb is not a straight line. Why is that? As the filament in a bulb is made of metal that consists of an ionic lattice surrounded by 3 electrons. The higher the current, the hotter the metal gets, and the more these ions vibrate. This makes it harder for the electrons to flow as they collide more frequently with the ions. That means the resistance gets higher at larger currents. That's why the graph is curved. But just remember that if you want to calculate the resistance from this graph, you always pick a point. You never draw a tangent on this graph ever. Question 8. What is true for electrical components in series and parallel? Bonus points if you can find the missing numbers. Components, say resistors in series, will have the same current, but the total PD will be shared between them. If the resistance is at the same, this PD is shared equally. If not, the larger resistor gets the larger share of the PD. So you can hopefully see that the 12 volts total here will get split into 8 volts and 4 volts according to the resistances. Components in parallel have the same PD, or rather their branches we should say. It's the current that shared this time, so there must be 0.4 amps flowing in the bottom branch. Using V equals IR, the missing resistance must be equal to 12 volts divided by 0.4 amps, that's equal to 30 ohms. Electricity questions pretty much always come down to this, using your knowledge of series and parallel circuits with Ohm's law. Question 9. What are thermistors and LDRs, and what do they do? They're special resistors. Their resistance changes. Thermistors' resistance will decrease if the temperature gets hotter, and so that means resistance will of course increase if the temperature goes down. It's kind of the opposite to a metal filament in that regard. An LDR is a light-dependent resistor. It works in a similar way to a thermistor, just at this time it's an increase in light intensity that causes the resistance to go down. Question 10. What is the voltage and frequency of UK mains electricity, and how is AC different to DC? Mains voltage here in the UK is 230 volts and its frequency is 50 Hz. It's AC alternating current, sometimes called alternating PD. The current and PD reverse directions so many times a second. DC is direct current or direct PD. The current and PD do not change direction. That's what you get out of batteries, for example. Question 11. What fuse would you need in the plug of a 2 kilowatt kettle? Here's a hint. You need the equation that links current and electrical power. You need the equation that links current and electrical power. We use P equals 4. We need the current, so rearranging we get current equals power divided by voltage. So 2000 watts, that's 2 kilowatts. Divided by 230, because that's mains voltage, gives us 8.7 amps. The three types of fuse we use are generally 3, 5, and 13 amps, so we need a 13 amp fuse for this kettle. Question 12. What are step-up and step-down transformers, and where and why are they needed in the national grid? A step-up transformer increases the voltage of the electricity from a power station before it enters the grid's network of cables. This is important as it decreases the current. This reduces the amount of energy or power lost as heat due to the resistance of the cables. A step-down transformer is at the other end. It reduces the voltage down to a much safer 230 volts for use in homes and businesses. Question 13. Just for triple. What kind of charge is at the center here, producing the electric field? Electric field lines show the direction of force on a positive charge if it was placed in the field. That would mean it's being repelled from whatever's at the center, so that must mean it's a positive charge at the center. Question 14. How do you find the density of regular and irregular objects? The equation for density is mass divided by volume. You get the mass by using a top pattern balance. For a regular object, that's an object for which the volume can be calculated. Say, a cuboid. You measure all three sides using a ruler or a vernier caliper. Then multiply all three sides together to get the volume. For an irregular object, say, for a chess piece, you submerge the object in a displacement or urea can. You collect the water, then put that into a measuring cylinder to find the volume. Question 15. What is the definition of internal energy? And why does temperature stay constant during the melting or evaporating of a substance? Internal energy is the sum of kinetic and potential energies of all particles in a substance. Temperature stays constant during a change of state because the energy supplied to the substance at these points is being used to overcome the forces of attraction between the particles. This only increases the potential energy of the particles. It's only once melted or evaporated that the kinetic energy of the particles can increase again, and this is an increase in temperature. Question 16. Here's the equation for specific heat capacity. That's changing thermal energy or heat equals mass in kilograms times specific heat capacity times temperature change in degrees Celsius. That's why I prefer delta T at the end personally. Anyway, what mass of water at 20 degrees Celsius initially can be boiled with 504 kilojoules of heat supplied? The SHD of water is 4,200 joules per kilogram per degree C. The boiling point of water is 100 degrees Celsius, so delta T is 80 degrees. We want to calculate M, so we need to rearrange the equation to get M equals delta E divided by C times delta T or delta theta. So 504,000 joules. Did you remember to convert kilojoules into joules by multiplying by 1,000? Divided by 4,200 times 80. That's our temperature difference. Don't forget your brackets again. That gives us 1.5 kilograms. Question 17. How much energy would it take to melt 50 grams of ice? We use the specific latent heat equation. E or delta E equals ml energy or heat equals mass in kilograms times the specific latent heat, so that's 0.05 kilograms times 334,000 joules per kilogram. That means we'd need 16,700 joules of energy to do this. Question 18. Explain the 3 ways you can increase gas pressure. You can decrease the volume or add more gas. Both of these result in particles colliding more frequently with the walls of the container, say the walls of a balloon. You can also heat the gas. This increases the kinetic energy of the particles, meaning they not only move faster so collide with the walls more frequently, but they also collide with a greater force. Question 19. Just for triple, the gas law for GCSE anyway is this. PV equals a constant for a container of gas if the temperature stays constant. Atmospheric gas pressure is 101 kilopascals. What would the new pressure be if you took some of this gas and compressed it to half the volume? The pressure would double to 202 kilopascals. This is because pressure and volume are inversely proportional. To prove it, we can write P1 V1 equals P2 V2, 1 just being before, 2 being after. We are arranging it to find P2, the pressure afterwards, and putting in the numbers, just using 1 and 0.5 for the volumes because we know it's just been halved, we end up with 202. As this is a proportionality or ratio question, ultimately, we can use the shortcut of not converting units. Our answer will just be in the same unit as what we put in kilopascals in this case. Question 20. What did Brotherhood discover about the atom and how? Brotherhood fired alpha particles which are positively charged at a thin gold leaf. Most went through, but some were deflected back. This shows every atom is mostly empty space, but they must have a small positive charge at the center, which we call the nucleus. Question 21. What are alpha, beta, and gamma radiation, and what are they stopped by? Alpha radiation is alpha particles which are essentially helium nuclei. That's 2 protons and 2 neutrons. They can be stopped or absorbed by a piece of paper. Beta or beta particles are high-energy electrons. They are absorbed by a few millimeters of aluminium. Gamma radiation is high-energy EM electromagnetic waves. They aren't stopped by anything, but they can be reduced by being absorbed by lead or concrete. Question 22. Complete these 2 nuclear decay equations. You'll definitely want to pause for this one. An alpha particle has a mass of 4 and a proton number atomic number of 2. Taking that away from the uranium numbers, we're left with 230 and 90 on the thorium nucleus. Left over. A beta particle has a mass of basically 0, so we put that as its mass, and it has an atomic number of -1, so the mass of the dorsal nucleus left over doesn't change, but be careful with the atomic number as it must go up by 1. Question 23. Give 3 sources of background radiation. Possible sources are cosmic rays, radon gas, medical equipment, nuclear weapons, and some food like bananas. Don't get me started on radioactive bananas. Question 24. Question 25. Just for triple, where does the energy come from in fission and fusion? During fission or fusion, the mass of the nuclear fuel decreases. This mass is turned into energy. Leave a like and a comment if you found this helpful. All the best in your exam, and I'll see you next time.